We're going to talk briefly about the definition of a function and how you can determine that from t-charts. But first, we need to back it up and make sure we know what the utility of a function is in the first place. We've done a piecewise function for how much it would cost to go see your counselor, which we decided was actually like a really healthy and adult thing for people to do. One of the things that we did was work out a pricing model that was based on how long you've spent there. And that seems reasonable. If you spend 15 minutes, that probably shouldn't cost as much as if you spend an hour and a half. You're taking up more of that person's time, you're requiring more of them, so it makes sense that you'd pay them more. But it'd be really frustrating if you went to that counselor on Monday and your 15-minute session cost $30, and then on Tuesday, your 15-minute session cost $50. Like, that same input feels unjust if it comes out a different dollar amount every time. And that is, in fact, the use of a function. A function is only useful to us if it's reliable. And so, when we're looking at inputs and outputs for a function, we're thinking about, is this reliably processing the information the same way? For this function here, f of x, when we plug in 0, we get out 0. When we plug in 1, we get 14. When we plug in 2, we get out 28. It almost seems like we're just multiplying the number by 14, except that this is under a little bit. It doesn't matter that I can't figure out exactly what the conversion rule is from the input to the output. The cool thing here is that every single time I plug a number in, I'm not getting duplicate information. In fact, I didn't even have the opportunity to get duplicate information. But based on this graph, I am predicting this table. I'm predicting that if I plugged in a 1 again, that I would still get out a 14. And that would feel fair, that would feel right. When I plugged in 1, I got out 14, so when I plug in 1, I get out 14 again. For function g of x, if I plug in 5, I get 25. If I plug in 7, I get 35. If I plug in 10, I get 50. But then if I plug in 5, I get 90. This is a problem because earlier when I plugged in 5, I got out 25. And then when I plugged in 5 a second time, I got 90. This is not a reliable conversion from inputs to outputs. This is not useful to us. If you went to the baseball park and bought 5 tickets and it cost $25, that would be kind of cool. But then if the window next to you, they bought 5 tickets and it cost them $90, that person is going to be really upset. They're going to be really frustrated at how unfair this whole situation feels. So this is actually not a function at all because it does not reliably convert inputs to consistent outputs. In order for this to have been a function, this would have had to come out the same way it did up here. One of the things that students will do here is then they will just look at the x values and be like, okay, 5, 7, 10, and then they see that it's duplicated. Oh, 2 5s? Not a function. That's not actually true. Check out this one right here. When I plug in 3, I get out 12. When I plug in 4, I get out 16. When I plug in 3 again, I still get out 12. And when I plug in 4, I still get out 15. So even though I've got 3 listed twice, this one actually still is a function because 3 reliably outputs 12 and 4 reliably outputs 16. So make sure that you are actually processing what a function is. It's reliable conversion of inputs to outputs. It doesn't necessarily mean that you can't do the same number twice. It just means that when you do the same number twice, you better expect the same output. And that's why G fails where H doesn't.